So the question is, why do you multiply this part and then add that part, and how can you describe that on a number line?
Would you add 3 plus 2, or would you like
So because that doesn't have a lot of meaning yet,
wouldn't you multiply 3
I want to show you on the number line, Noah.
Maybe it's because when you're making a mixed fraction, you divide.
It's true. It's the reverse, right? When you're going from an improper fraction to a mixed number, you divide. So it would be logical to go from a mixed number to an improper that you would multiply. But my question is, why does it work? So I want you guys to always think about why things work. So if I look at this and I see my denominator as thirds, I'm going to make a number line and I'm just going to break it into thirds. So in other words, that's going to be 1, and that's going to be 2, and that's going to be 3, and I'm going to go up to 4.
How do we know how big they are?
They just have to be even sized. So can you see this is 1, this is 2, this is 3, and this is 4.
I like that too. That looks nice.
Thank you. And this would be a third, right? And this would be 1 and 1/3 right here.
Are we just trying to put a dot where it's
Exactly. So 3 and 2/3, if you think about it, it's way to the right. But it's 3 wholes, so 3 big jumps, right? And 2 third-size jumps. So the dot's right here. So that's 3 and 2/3. Don't you guys agree with that?
Yeah.
How many thirds is it all together?
11.
11.
Oh, I get it.
Right? It's 11 thirds because there's 3 thirds here. So if I trace over the thirds, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 thirds. So the mixed number 3 and 2/3 is the same as 11 thirds. So this little rule you learned in elementary school, there's a reason it works. Don't forget to keep meaning to math rules as much as possible.
It's like you do 3 times 3, which is 9, and then you add the 2, you don't do 3 plus 2.
Right, because you know that there's 3 sets of thirds, and then there's 2 more little thirds. So it's 3 times 3, which is 9, and then you add the 2 and you get the 11. So let's do it the reverse way here. Here there's a negative. So the only thing that's different here is your 0. We're going to go to I'm going to put my 0 here because negatives go to the left. Okay? And I'm going to break my little line into fifths. Okay, and again, I'm just going to make them consistent. So 1, 2, 3, 4, 5. 2, 3, 4, 5. So this is -1 because I'm 1 unit away from 0 in the left direction. Does that make sense? And then this is -2. And we're going to spend a little more time talking about negatives today, so hang tight if that doesn't make sense. And then I'm going to go 1, 2, 3, 4, 5. So this is -3.
Then that's all we need.
That's all we need. Okay? So we're going to do 2 jumps, 2 whole jumps, 1, 2, and 3 little jumps. So right here is -2 and 3/5. How many fifths is it all together? Yeah, there's 5 here, right? 5 here, that's 10, 11, 12, 13. So the shortcut is to multiply these and add that. 2 times 5 is 10. That's 2 sets of 5 plus 3. So it's -13
Although if you
fifths.
go to the negative side, it's wrong, right?
Yes, it's negative. It has to stay negative because you went left instead of right.
Or do you want it to be a proper fraction?
That's a great question. There are times that you don't want a proper fraction. Sometimes it's useful to have an improper fraction. So it just depends. It just depends. It's a great question. There are just times when it's helpful to have it improper. Like in a ratio table, you
want it improper.
you have a lot of improper fractions. Troy.
You can also do this. You can do the, it's like 3 and 2/3. You can do 3 times the denominator, which is 3 times 3, and then add that to 2, which is 11/3.
Right? That's
really
what.
you're doing.
That's right. So that was the shortcut. You're exactly right. I just erased it because it was looking a little messy. You multiply these and you add that, and that's really what we want you to do. But we want you to know why that works, and we want you to be able to look at a picture too and make sense of it. Because sometimes you have all these little rules and you don't know why they work, and then it's hard to remember them. So if you forget the rule, you could always draw the picture, and then you'll remember the rule. Okay, so this we've done a lot of. This is just going backwards, right? So we know 5 goes into 12 twice, right?
5 at the bottom and 2 at the top.
And the remainder, when 5 goes into 12, is 2 and 5, right? So I think we practiced that one a lot. I don't think you need to draw a number line, but you surely can if you're still trying to make sense of that. So if this is 0 right here, and I had 12/5, I just put 12 little jumps, but fifths, that's one hole right there. That's 5/5. And then 1, 2, 3, 4, 5, that's 2 holes, which is 10/5. And then this is 12/5. I'll move out of the way. Sorry there. So this is 2 and 2/5. So it's just a picture to go with the rule, but the answer, I think we've worked on going this direction a lot last week. I don't think you need as much practice. Am I correct on that? Okay. So, want to do this one for me, Camille? Without a number line?
The 4 goes into 23 5 times.
Right.
And 3 is left over.
Right.
So it's 5 and 3/4.
Right. And the denominator stays the same.
Or 5.75.
Yes, and if you needed the decimal, it would be 5.75.
The other one would be 2.2.
And the other one would be 2.4.
2.4.
Right. This decimal, good use of those, that's 2.4. This is 5.75. How about that one?
Which one?
This one.
Oh, that's negative.
Negative 2.
Negative 2 is 6.
Right, good job, Chase. Negative 2.6. What about this one up here?
Negative. Or no, negative
3.
0.66.
Right, right. So those are the decimals. Even though we aren't doing that, it's great to practice that all the time. All the time. Even when you're not asked, just to get those down. Okay? So I'm going to do a couple examples, but I'm going to just post those notes. Let's make that a little quick video. So let's